So we kind of left off around here, perhaps a little bit, a couple of slides later, or I think a couple of slides later. So we see this diagram of a network of networks. So we've got these two quite separate networks, autonomous systems. They have no connection with each other except through this, this could be like in the internet somewhere, these exterior routers. And so we've divided up these routers or classified them into types of routers called core routers, edge routers, and exterior routers. So your core routers are within the network and they're not connecting to anything that's outside the network. The edge connectors are connecting between the network and outside. So between routers inside the network and the outside. And then we have exterior routers, which are nothing to do with our network, which are just things that we connect to if we want to access other network outside of our own. And so we did talk about this as well. We tend to think of layer 2 as being where switches are, and that's true. However, some of the functions of a router can be undertaken by a switch, a higher level switch. And so that will actually make your networking a little bit more easier for you to do it, so that you could have switches within the network. Remember, switches only work within a network, whereas routers can work between networks. So you can have switches which have the speed of a switch, but have the flexibility of a router. And so that's the idea of our layer, what we call layer 3 and 4 routers, sorry, switches. The routing table is kept in the memory of the router. So the router keeps in its table a memory of what connections it is connected to, basically. And so based on the routing table, it knows where to send a packet by its destination address. It can analyze the destination address of a packet that comes to it, and then send it to the best router on the next hop through the network. And so that's all contained in the routing table, and the routing table is in the memory of the router. So I think the idea of this diagram is just to show that if you're if you're looking at router B, it would have a routing table, which would basically say, if you want to go to the internet, go out this port, connect through this port. If you wanted to go to this network here, LAN D, then you're going to the next place that you'll look is router C. If you wanted to go to LAN C, then you're probably the next place you'll look is a router C. However, you could get there through router A, but you would go through router C because that's quicker. If you wanted to go to either LAN A or LAN B, well, if you were going to LAN A, you would go through router A. But if you wanted to go to LAN B, you just we just go out one of our ports here, which just goes to a switch. So all of that information would be in a router table. So for each of those, so when we got a packet that had an address for this network printer, that would be directed to router C. And if we had a packet that was addressed to one of these PCs here, that would be sent out the router port to switch B, and etc. So that's the idea of the router table. We can, as a network administrator, we can build the routing table ourselves. We've got commands that we can do that with. So we can just basically configure by logging onto the router and entering the commands. We can configure the routing table ourselves by adding things to it. Otherwise, we can configure the routing table so that it has a protocol which is going to create the routing table for us. So that's what we call dynamic routing. Basically, how that will work is it will send out messages to out all of its ports and see what comes back. And by what comes back, it'll be able to tell where that router is. And so we'll then be able to know what things to send in which directions. I think we did actually talk about this. This is a bit of revision. I think we did go through this a bit. So I started a bit earlier. We have these commands, route command, show IP. You can try these on the command line, and we'll look at that after the lecture. We'll look at, because that's actually what the activity is. The activity is to open up your command line and try these commands. So we can try the route command. They all are sort of similar. It's interesting that they're similar. You might say, well, these are differing operating systems, but to be honest, they all kind of have a sort of a history. If you go back, it's like family histories. Go back to the family history, certainly for the Apple operating system, it is descended from a Unix type system, a Unix Linux type system. And even the Windows, which was descended from MS-DOS, which kind of looked a little bit like a little bit of Unix in the oldest, well, actually CPM, but CPM, Unix been around for a long time. And so that sort of came from that. Routing metrics. When we have some commands which we can use to test on our routing, and you'll see that, for example, we can test, we can do tracers, and we can test the hop count between one device and another. We've got these other things that we can test, how long it takes, maximum transmission units, etc. So that's all possible with the commands. Some of these commands we can do straight from the command line. I think this is where we kind of ended off, right? So I think I remember we were talking, oh, sorry, that's different for you. Yes, I think we were talking about commands, sorry, about the protocols. We just got to that point. We were talking about convergence, which would be the time that it would take to sort of build up those tables. And so when you just turn on a network, the routers, it takes some time for the network to sort of converge. So we have a table now of a bunch of protocols, and these are routing protocols. So remember a minute ago, I told you we could do static routing. The alternative is some kind of dynamic routing, in which case we have to assign a protocol to the router, and then the router will build up its table based on the protocol. And so our routing protocols are two different types. We've got our IGPs and our EIP. So our internal protocols and our external protocols. What we're talking about there, internal to our own network, or protocols that sort of span over the world of networks. And so we only have one of these EGPs, all the rest are IGPs, border gateway protocol. So this last one is sort of different than all the others, and that comes up in the next couple of slides as well. So bear with me, I'm using two computers because my HDMI cable, I thought I had a bad connection downstairs. Turns out my HDMI cable, thought that was the problem. Might be. It's either my HDMI cable or it's my HDMI port. I got a feeling it might be my HDMI port, which means time for me to buy a new laptop. Or get the port fixed, but this is like a 2015 one or something. Yeah, time for a new laptop. So as we said, they're interior gateway protocols. They come in two types, distance vector and link state. And so these work differently, right? So let's look at how they work differently. The distance vector, what it does is calculates the path based on the distance to that destination. Distance to that destination, by that it means sort of distance in terms of routers, etc. The link state protocols, what that does is it communicates to the neighboring routers, and it asks them, the link state basically sends a message to the joining routers and says, can you please send me a copy of your routing table? Basically, that's how it works. And so I don't want to do that. Okay, so I don't want to make it sound like computers think and talk like humans, because they don't. But basically what it does is it requests a routing table from the other one, and the other one will send it a routing table. And then it's easier for it to build its own routing table based on the other. So you can see that that's gonna, the link state, that's a lot of data it's got to send, right? So that's gonna take a little longer to sort of get going. Distance, it could be. Distance vector is going to be simpler, but it might take longer to calculate. All right, so it depends on how your network is, which one of those is going to be better. Now your exterior protocols, well, we only have one. We can't use, seems like we only have one at the moment, and that's called BGP. But the thing about it is that that is sort of goes out into the wild of the internet, et cetera, and is able to sort of span from one end of the network to the other. Whereas your link state, et cetera, and your distance vector, we're really just communicating with the adjacent routers. I'm not going backwards, am I? Because we already looked at no, we didn't. So this one has actually got the same diagram, but it's got some information on it that didn't have before. So basically what we're seeing is within each of these clouds, we're using the IGP, so there's like 5 of them there, or 4 of them. So the RIP, OSPF, ISIS, and EIGRP. These are routing protocols that could be used inside our own sort of autonomous network. Outside the autonomous network, we use BGP. So BGP, I hope you see that, right? So we're using internal gateway protocols inside our autonomous networks. Outside in the wild, we're using to span across the whole internet, we're using the BGP. BGP is the only protocol that communicates across the internet. So that's what that diagram is trying to show you. So back to these other protocols, which are IGP protocols. And so we have the OSPF, the open shortest path first. It says here that it's one of the earliest ones, but it's an improvement on the RIP. So IRP was a very early sort of protocol. So what does it do? It uses an algorithm to determine the shortest paths. Seems like a good idea. So hold on a second. Yeah. So the RIP routing information protocol. That's one of the oldest ones, and it was distance vector. So remember, there's 2 different types of IGP protocols. There's the distance vector, and the link state. And so OSPF, is it also? Okay, what about it? It shares data, maintains the data. So doesn't that sound like a link state? Shares data, maintains database of other routers' links. Low overhead, fast convergence, stability, prevents loops. Very nice, but it's a bit old. ISIS, intermediate system to intermediate system. IGP, link state. Again, it's link state. So that's going to, it's kind of similar to OSPF. From what this sounded like, it sounded like, yeah, that was OSPF was a link state. Like I said, keeps a copy of a database of the other routers, routing table. So ISIS is like that. It's link state, and it does a best path. It's kind of like OSPF, but I guess a new and improved one. It's new and improved because it works with IP version 6, whereas the other ones, the older ones, OSPF, etc., are working only with IP version 4. So if you want to use IP version 6, people are going to like this ISIS. Service providers like it because it works with version 6. EIGP, advanced distance vector. So distance vector is different than link state, remember? So distance vector is just going to work on the distance, but it's referred to as a hybrid, has a fast convergence time, low network overhead because it's not passing routing tables over the network. It's easy to configure, multiple protocols. Cisco used to own it. BGP, when we get to BGP, now we're talking about exterior or border. BGP is a border gateway protocol, but it's the only exterior gateway protocol. So it's able to go across systems that it doesn't know about, autonomous systems, to go between them, and determines best path, etc. Am I recording this? Oh, yes, I am. So that's good. And that brings us to the end of our little discussion about routing protocols. So just a little bit here about troubleshooting. What you're going to see in the next few slides, you're going to see some of the commands that we can use. and how we can use them to find out what's wrong with our network. And so that's kind of how we use these. And so let's have a look at some of them. All right, so we got netstat. You will see later here a table of these and how we use them. And we can sort of have some fun with these. Basically, you can go, most of these, you can go to your command line and you can use the command and it will tell you different things, right? So it gives you some information, what port TCP is working, network connections that are currently established. We'll look at some of these in a minute. I don't know, it's better to do that than do it while we're going? I think so. We'll just cruise through here and then at the end, we'll look at some of these commands. Netstat, let's remember to look at that one. So here's some of the parameters that you can add to netstat. And so for example, if you did a netstat -A, this all the current TCP connections and all the listening TCP and UDP ports. Whereas on the other hand, if you did a netstat -R, you could display routing table information. That'd be cool. Or if you did a netstat -N, you could list current connections, including IP addresses and ports, which could be cool. So if you want to know a little bit about your network, what's connected to you immediately, you can try the netstat command. And you can try that from the command line. We'll try that in a minute. Okay, sorry, trace root or trace root. So trace root is going to sort of work by distance. It's going to show you the hops that you have between your routers on your way between one place and another. So trace root. So what it does is it communicates to each of the routers on its path to where you want to go, and eventually it might time out, but it can give you some information about what are the routers on the way to the place where you're going. It's kind of cool. We'll try that one. Trace root. Might stop before reaching. Yeah, it might stop because it might be stopped by the device that you're trying to see it, which will not accept it. Maybe too busy, and maybe there's you may run into some connection issues with the particular packet that's being sent. All right. So it's not really going to detect problems with routers, but it's just going to tell you sort of distances and things like that. It's kind of cool. We'll try that one. Path ping, Windows combines ping and tracert. So ping is your sort of basic level, introductory, simplest way of sort of telling if you've got a connection between two devices. You ping the IP address of the other device, and if you get the packet back, then you've got a connection. If not, then you don't. Sorry, I didn't update that, so we sort of came to here. Path ping seems to be a bit of an improvement on that. TCP dump. Now, TCP dump, it's a packet sniffer. I think you have to install this on there, or look, it runs on Linux. It's not kind of working on my, yeah, see, you got to do sudo command with it and log in, do TCP dump. So that's not going to work on your personal computer if you try that, unless you happen to have Unix or Linux installed. But if you did, then it can do packet sniffing. Wireshark, any of you guys ever installed Wireshark? Wireshark's free, and it does packet sniffing for you. It'll do it's really nice, but it's not built into your computer. You have to download it and install it. So that would be one to look at later, but TCP dump seems to do something like that. And so here's a bunch of commands that go with TCP dump. As I said, we're not going to be able to do these on our computers at the moment because we don't have Unix, Linux. But if we did, there's some things that we could do. Wouldn't that be cool, right? Number of packets captured, filters out different types of packets. So that'd be cool. Filter out SSH and telnet packets so people can't hack in and sort of remotely control your network devices. This TCPIP dump -I any interfaces on the device. There's a bunch of things there that you can sort of use with it. Oh, now we're getting into some more standard type things that you will be using. ARP. ARP is going to tell you what's going on in the ARP table. ARP table is going to be, remember, it's a map IP addresses to, so that's within a network. So it's not quite like a like your routing table. It's a different table. You got tables on your switches as well. And so the ARP is going to tell you how you map an IP address to a MAC address. That'd be useful. Right, so DNS servers, Dig is going to tell you a little bit about DSS. Now, when it says command line utilities, these should work on your operating system. Now, it does give you a qualification there that path ping, as we described, doesn't work on our device, Windows, but it works on Mac, it works on Linux and Unix. But these others work for us: root, netstat, nmap, nslookup. So I kind of encourage you to sort of have a play with those. You're not really going to be able to hurt your network playing with them. So that'll be something to do. And actually, that's kind of what your exercise is for Lab 3, is to sort of have a play with them. That would be really bad, what this slide is saying. Wouldn't that be bad? If you had two devices with the same MAC address. Well, if you had that, then you could have all kinds of security issues. It shouldn't happen, right? I mean, it shouldn't happen because every device should have a unique MAC address for every port. So unless you can sort of spoof it, then you would be a hacker, right? If you were able to copy somebody else's MAC address, you could impersonate them on the network, I suppose. Happens most often when managing virtual devices. Aha, virtual devices. So most switches will detect the problem and will help you solve it. That's good to know. All right, so ping, trace route. These are going to help you to know if there's some node or some host in your network which is not really connecting properly. That's what we would use these for, is to sort of see if we've got connectivity. See how our connectivity works from end to end. If we want to discover neighboring devices, so ARP is going to tell us what are the MAC addresses of things near us. We've got some other things there. Neighbor discover protocol for IP version 6. And there we go. We're in summary here. We started this lesson 2 days ago, I think, or yesterday. We were talking about TCPIP, protocol stack, and then of course we had to talk about TCP and UDP, which are the two protocols that work at the transport layer, and they have their individual strengths and weaknesses. So your TCP is more secure, but it's slower. Your IP, which really makes the internet possible, because your IP is your logical unique identifier for each device on the network. ICMP is a packet sort of thing that works with that, that allows you to sort of probe other devices and see what's happening with them. So for example, ping uses an ICMP packet. ARP, to give you information about the MAC address from the IP version 4. And we talked about that over and over again in the last couple minutes. So routers. Router is the magic sauce of computer networking and the internet, isn't it? So what I mean by that is it's the thing that makes it possible, because the router provides an interface between two different networks. So that router that you got in your house, that's giving you an interface between your home network and Arito's network. And then from there, there's lots of other routers that we can sort of route packets through, and that's what routers do. They actually receive a frame, but they take off the frame has the front address of the frame is the MAC address of the router port. Sorry. Yes, so that slows. So routers are slower than switches for that reason, because switches don't have to take off the frame header. They can just switch the frame straight through, whereas a router has to take off the frame header, analyze it. Oh, which port am I going to go through? All right, that one. Now I'll put on another frame, and then send it out. So a router's got a bit more work to do. So it's slower. It is slower than a switch. So that's maybe why we have layer 3 and layer 4 switches, right? Because switch is going to be faster. And so we talked about static and dynamic routing. Static routing, where we tell the we set up the routing table by adding to it using some interface into the router. The dynamic routing then is built up by the router using a particular protocol, and we talked about a lot of those protocols. Route command is going to let us look at that routing table. All right, and so what else we got? We got a bunch of things about the router is actually kind of a high-end computer in some ways. Oh, well, high-end, I should be careful how I use that word. Yeah, it's a computer, and so it's doing some processing to figure out where to send the next packet, and that's kind of the magic sauce that I was talking about. We have, what else here? We got the different protocols, the interior and the exterior protocols. Most of them are interior, but the interior ones were divided into two types. Remember, we had the link state ones and the distance vector. And I think that I explained that over and over again. But distance vector is just figuring out the distance to the next one, and then pick based on that. Not to the next one, but to where you want to go. Whereas your link state, what it's going to do is actually just take copies of everybody else's routing table, and so it'll work out its own routing table based on that. Then we've got all these nice commands here: ping, ipconfig, ifconfig. Ifconfig, we don't use that for Linux or whatever. And let's look up dig, ARP, route, netstat, traceroute, path ping, again, Linux. TCP dump, again, Linux. So we're running out of time. We got 10 minutes. So let's stop there on that. That's the last slide anyways. Alhamdulillah, they said. Or was it just me? Okay, so let's look now at what else have we got. Oh, I hope I didn't close the window. There it is, class list. So the other things that you've got to do is you've got this little exercise to do, and I have put up a, this is a Dropbox. So before you can go to the Dropbox, maybe might be an idea to open up the class activity. And the class activity is going to be to do some of these nifty commands so that you can test out and see how that works. So you're going to need to do, your CMD. I've got that here, but just in case some of you can't remember. Are you guys, can you still see my screen? Yeah, it's still sharing my screen, right? So just in case you can't remember, if you just go down to your taskbar and choose CMD, that's a command prompt and gives you a window. And it's like using the old days of using, what do you call it? MS-DOS. Back in the good old days of MS-DOS, we used to use this. So I'll show you what I mean by that. We got all the DOS commands we can use. Oh, gee, that's ugly. I don't know what that is. So dir star. That's an old DOS command. What it does is shows you all the directories you got there. Okay, you know, you don't need to use that. We're not using DOS, but what we are using is we're using ipconfig. And ipconfig tells you some stuff like what's your IP address, what's your default gateway, and some other cool stuff. All right, so that's ipconfig, and there are various. I think that if I so it tells you what are the commands that go with it. So ipconfig all the detailed information. So all release, blah blah. So yeah, there's a bunch of parameters that can go with it. I don't need to use minus. All right. So yeah, okay. Is there some information there that's useful? I don't know. Didn't do anything. Unrecognized command. maybe I do need to do the dash. IP config. All right, so that's giving, so do a dash, and that's giving me a lot of really cool information that's going on right now, you know. So tell me about my wireless LAN, about my Ethernet adapter, and basically about my adapters connecting to the internet. Media state, media disconnected. Oh yeah, these are just different adapters, how they are at the moment. So that's kind of cool. And then the standard information that we really want, things like what is our IP address and what is the subnet mask. That's good, right? What is our DNS server address? Oh, how about that? So it even has our MAC address. So that's pretty neat, the IP. So look at that. If you did the IP, I kind of answered this one for you, right? By doing the IP config -all, you could get the IP version 4 address. So for example, mine is there. And so I did an IP config -all, and I got this, and the subnet mask is there. Mine's 255.255.248.0. But yours is going to be different. Don't write down my numbers. Yours is different, right? My default gateway is 192.168.128.1, and yours is going to be different. But all of that information was available through one little command, IP config -all. Compare your results with your neighbors. All right, so we did it again. This time add the option all. Well, we did that. In your browser, Wireshark. Look at that. You can do Wireshark on the internet at wireshark.org. Find the manufacturer of your PC. Let's see about that. Let's go to our browser and try that. We're gonna run out of time in a minute, but you know, I've never used, whenever I've used Wireshark, I've used it, I've installed it. I haven't got it on this machine, but you can see how it says Wireshark download. That's how I've done it. But apparently you can do something from Wireshark.org. Let's see. It's exciting. Okay, so there's a download. Maybe he's suggesting that you need to do the download. Well, yeah. Okay, so do that. I'm gonna do the download too, because I used to have Wireshark on this computer. I'm pretty sure, but I don't have it. So I'm gonna just do the Windows 64 version. And because this is my laptop, I do have admin rights. It's gonna take a minute for that to work. Okay, what else have we got going on here? I think it's in here. So get Wireshark and find the IP addresses. Okay, using this command. Get your Wireshark and find out the manufacturer of your NIC. So you guys can do that one on your own, but try this command. I think this meant to be CNA, not CAN. So try NS lookup and then the name of a thing. So I'm going to try that now. What I'm going to do is I'm going to not show all there. I'm going to try and get my, I can't get my, the problem is if I'm sharing my window with you, I can't, yeah, maybe I can. No, I can't. If I'm sharing my window with you, I can't, oh, there I can. You guys still see my window? Yes, I am recording the windows. I'm still recording, I think. So what with this one was we wanted to, oh, there's my command line all right there, actually. What we wanted to do is we wanted to, what was that we wanted to do? We wanted to, we wanted to do NS lookup. NS lookup on our thing. So where's my window for, I got to close this like that, really? Okay, so NS lookup, I hope you can see this. NS lookup and then www CNA Qatar QA, I guess. Or is it COM? Is it COM or QA? COM. And it timed out first. Okay, so then it gave me the IP address for that URL. I mean, I don't know if you guys can see that. Still says I'm still sharing, but this says 212.77.204.141. So that is the IP address. Let's try it again. So this time I'm going to do it with Amazon. So we can hack them, right? Oh, no, I did not say that. All right, so Amazon apparently is at 172. Ooh, you know, that's, I don't know, man. That's not us. That's not Amazon. They got it. Ooh. So Amazon sort of kind of like hidden theirs. Because if you look at this 172 thing, that's our network. Yeah, that's not Amazon. So they just timed out and said, you know, no, we're not telling you what our IP address is. I'm sure we got other ways of doing it. All right. But we're not going to be able to do it with NS lookup. Do you remember some of the other ones? NStat? Yeah. I think that was one of them. Spell it right. Do you remember what it was? Almost. And so that gives me a list of things that are connected. Kind of cool. There's a lot of other ones that you can there. NS lookup is done, right? All right. So out and